you want to say the prayer or shall I?
I'll say it. Dear Heavenly Father, we're thankful for this day, and we're thankful that we were able to meet together, and yes, that we'll be able to have everything that we've learned through the semester come to our remembrance, and that we'll be able to know how we can apply these things to our lives, and yes, that we'll be able to get everything out of this that we need to, and we say this in the name of Jesus Christ. Amen.
Amen. Thank you. Okay, I'll just do question 2 then. Which of the following variables is or are quantitative? I would say the first one and the third one.
I was thinking the second and the third.
You're thinking the second?
Yeah, the 3 most common brands of car and the number of people.
So quantitative is a number, right?
Yeah.
Okay, so I guess the telephone number really of randomly selected. Okay, I see that. Okay, I would agree with that. Okay.
All right. Students in an introductory statistics class at BYU, Idaho are studying prices of cold cereal at grocery stores in Rexburg. To get a sample of cold cereal prices, they went to Albertsons and rolled a die to decide which box from the left of the top shelf they would start on. They then recorded every 6th cereal after the first, moving from left to right down the shelves, recording the name, size, and price of each cereal in their sample. Is this study an experiment or an observational study, and why? I thought it was an observational study because students had no control over the price of the individual cereals.
That's what I had thought when I did it.
Okay. Mike just said he's not going to be able to make it tonight.
Okay. I don't blame him. He's graduating.
Yeah.
You just do you have your email being able to pop right up?
It kind of pops up in the bottom of my screen whenever a message is sent to me.
How did you do that?
I'm not sure. I think it's just kind of how my computer was set up.
Oh, okay.
But yeah, I'm not sure how to set that up.
It's a good idea.
Yeah.
Okay. Question 4. For a Math 221 project, one group of students studied the ages of students on the BYU Idaho campus. They collected the data from a random sample of n equals 100 students. The sample mean was 21.2 and the sample standard deviation was 2.61. An excerpt of their data is given. I think we had this on a different test. The group notices an error in the data. The age of one of the males was entered incorrectly. He was actually 21 years old. When the error is corrected, what will happen to the sample median? Would increase, right? Or you think it
me would not sure about the median, because it might increase or it might stay the same.
Okay, so the mean is the middle.
The mean is just like the average of all of them.
Okay.
And the median is like the number in the middle. So if you're counting like if you count from 0 or 1 to like 50, it'll be number 50, and then you count from 99 to 50, it'll be that 50th number.
Okay.
So it might increase, but it might not increase if there was a lot of like 21s or whatever.
Okay.
Does that make sense?
Yeah, it's not. Hmm.
Because I was thinking it's not possible to determine this without the full data set. Because say if the 49th number was 21 and the 50th was also 21 or 22, then like if you had to switch that 12 to a 21, then it would move that back to there. It might make it the same.
Okay.
That's what I'm thinking.
Okay. We'll go with that. Because I guess I was thinking of the mean, because that definitely would increase.
Yeah, if it was a mean, it would definitely increase.
Okay.
The time to complete a standardized exam in the BYU Idaho Testing Center is approximately normal with a mean of 70 minutes and a standard deviation of 10 minutes. Using the 68, 95, 99.7 rule, approximately what percentage of students will complete the exam in under 50 minutes? I got 2.5%.
How did you do that again?
So 70 minutes is the mean. 60 minutes would be one standard deviation away from the mean, and then 50 would be two standard deviations away. And one standard deviation would be the 99.7, and two standard deviations away from it would be 95. So then that leaves 5% less than or greater than that percentage.
Then you have to divide it in half.
Yeah, because it's just less than, it's not greater than.
Okay. When I went back looking at that one, that was one I forgot how to do. It's like, wow, did I forgot? Okay. Let me see if I wrote this down. So the scores on the LSAT are approximately normal with a mean of 150.7 and a standard deviation of 10.2. Queen's School of Business in Kingston, Ontario requires a minimum LSAT score of 157 for admission. Find the 35 percentile of the LSAT scores if you're accurate. So when I did that with the applet, would I have first minus 150.7 from 157 divided by the standard? And that would have given me the number I needed, right?
That would give you the Z-score. Yeah, I'm not really sure because it's asking for the 35th percentile. So do you have to find?
I didn't know if I put in that in the applet, the Z-score, and then did the 35 on the top. Would that have been right?
I think if you put the 35 on top in the area thing, I think it changes the Z-score anyways.
Right.
So I think basically, I think what you have to do is put the like 0.35 in the area and only have the left area shaded.
Okay.
And then you find a Z-score. But I think the answer has to be I don't know. I think we have to use the Z-score that we find to find like the 35th percentile for the score, for the LSAT score.
But when I did that z-score of 150.7 minus 157 divided by 10.2, I got a negative 0.618. And then I put that in, and then I shade to the other. The probability says 0.268.
Yeah,
Is that what you got?
that's what I got, but I don't think, because that's the 27th percentile then.
So would it be both shaded, middle and? Or are you just putting in 35 at the top?
Yeah, so I think you have to put 35 at the top, 0.35.
Okay,
But then it changes the z-score.
right.
And then I think we have to find an LSAT score, like a number like 157, from that z-score. But I'm not really sure. I think we have to plug in that z-score and try to find a new score. So it'd be like, lost. So it'd be like, the equation would look like negative 0.385 equals 157 minus 150.7
Yeah.
divided by 10.2, or not, yeah.
Is that working both sides then? Okay, I see what you're saying.
Except for substitute the 157 with an X.
Mm-hmm.
Because we don't want to use 157. We want to find the actual LSAT score for the 35th percentile.
Hey guys, sorry I'm late.
It's all right.
Super late.
Oh, we're just at a good place for you to help us.
Yeah.
Okay, what number are we on?
We're on 6.
Okay.
How are you tonight?
Good, I just got back from work. Had some late night stuff going on, so that was fun.
Did you want the answers for the other ones that we came up with?
No, I won't make you go back. I can do those.
Okay.
And if I have questions, I'll watch the video.
Okay. Yeah, because I'm kind of a little confused on 6, what to do for sure, because I did 150.7 minus the 157 divided by the 10.2, and I got a z-score, but I don't know what else to do with that.
How many questions is this? Ugh. Ugh.
I know.
Oh boy. Okay, I'm sorry, what number?
6.
Oh, not too bad. Okay. Let me pull up the applet. Pen and paper.
I have totally forgot how to do these.
Yeah. So I don't know if this is what you're doing, but I went ahead and I put in the area. I shaded the area left and typed in 0.35 in the area box. That way we can find the z-score and we can kind of work it backwards. Is that what you guys were doing?
Yeah, you were starting that.
And I got for the z-score negative 0.385.
Yes. Mm-hmm.
Minus 6. So we're solving for x. So it should be x minus 150.7 divided by the square root of 10.2 equals negative 0.385, right?
Yeah,
Okay.
you have to work both sides.
Yeah. Dandy dandy.
I forgot the square root.
Okay, I got 149.470.
What did you get?
149.5 if you do one decimal spot. Thomas.
Um,
Is that what you got, Ross?
I'm trying to plug it in. I keep getting higher numbers for some reason. I don't know what I'm doing wrong. First time I got like 480, and the second time I got 47.
Well, let's go with 149. That one and move on. And if we get it wrong, we'll come back. How about that?
All right, sounds good.
And so we have lots of questions. We don't want to get stuck on one. Let's just keep moving.
You have a lot of questions.
Okay. You want to take 7, Lily?
What did you get? 149.52, Catherine?
No, I got 151, but we're going to go with that. I don't know how I got mine either, so.
I think it needs to be lower than 150 though, because the 35th percentile is negative z-score, so it should be a little bit lower. Okay.
I agree. That's why I said I'll just move on because mine wasn't working right either.
Okay. I'll take the next one. A team of dermatological researchers are studying skin cancer among 60 to 7-year-old American men. Suppose you're part of a research team and take a sample of men from this age group and calculate the mean number of skin skin cancer spots in the sample. Also suppose that it is known that the distribution of the number of cancer spots is right skewed. Suppose that the sample size for the study was n equals 2. What would be the shape of the sample mean? Right, skewed, right? Because it's not enough people, so it wouldn't be normal.
Yeah, I think it's skewed, right?
Yeah, that's what I agree.
We are an awful research team if we only have 2 subjects.
Yeah.
Nobody wants to be on that team.
Mm-mm.
Okay. Use the following information to answer the next 2 questions. Tanker trucks are designed to carry huge quantities of gasoline from refineries to filling stations. A factory that manufactures the tank of the trucks claims to manufacture tanks with a capacity of 8,550 gallons of gasoline. The actual capacity of the tanks is normally distributed with a mean of 8,544 gallons and a standard of 12. Suppose that a simple random sample of n equals 20 is selected and the sample mean capacity is found to be 850 gallons. What is the z-score corresponding to the sample mean? Round your answer to 3 decimals. I did this earlier and hopefully I got it right. We had 0.112. If I did.
Give me 1 second.
Guys, here's my paper. Problem, right? Number 8, where are you?
What did you get?
0.112. Is that I had to do 80550 minus 8544 divide by 12. Is that right?
Did you take the square root of 12?
I did not take the square root of 12.
Are we supposed to take the square root of 12? I can't.
I didn't remember that when I looked at I was looking at my sheet. Thought it was just the dividing of the standard deviation. I don't know where it happened. I did write it down, but you know, with all these papers everywhere. Because I am definitely a paper person. So yeah, it would have been. It could have been if I'm looking for the z-score and it's 1.
Yeah, you're right. When do you take the square root?
I think that's with the number because it's you have your value minus mean, and then you can divide it by the standard deviation. But if you have the number in it as well, then you have to divide it by the standard deviation divided by square root of n.
That's right. Well, that means I did the last one, number 6, wrong. Hold on. I'm going to run back to that one. Yeah, that makes more sense. Okay, for number 6, it should be 146.8.
Okay.
Okay, and then so number 8 was 0.112.
Yes.
Okay.
For 8, I got 2.236.
What did you do that so that I can understand that?
So I did, here, I'll show you my,
Because we have to take the square root of 20, right?
yeah, this is
Oh,
the equation I used right here.
okay. I don't. Come on, get up there. You did. Okay.
Sorry, I'm going to look at your page really fast. Yeah, that looks right.
What did you get?
I got 2.236.
2.236.
Yeah.
Hey, Lily, how do you look at his screen, at his paper when you were looking at that closer?
So when I clicked on the Google Hangouts page, I just clicked on Ross's name and it pulled up his screen.
Okay.
So were you able to do that?
No, because I was thinking, where's Ross's name at, other than on my bottom screen?
Yeah,
Yeah,
at
that's
the bottom, you just click on that little box that Ross's face is normally at.
Oh, okay. Now I see it.
And now it'll stay up so you can keep watching.
Yeah, it'll be,
And then the square root of 20. Okay. I just did without the square root. Okay. Then how do I get out of that?
I
I'm
think
not sure.
unlocks it.
Oh, unbox it?
Yeah, I think you just click it again and it'll
Okay. Thank you.
unlock it.
I got you back out.
Yeah. Yeah.
What is the probability that the sample mean capacity of 50 randomly selected tanks will be greater than 8540? So I think you just take basically the same equation and change 8550 to 8540 and change the 20 to 50. And
Take him.
7 and uh, 0.65.
Oh. For the Z-score? Oh no, for what did you get for the Z-score?
For the Z-score, I got negative 2.357.
Okay, good. Me too.
Yeah.
And then I think you shade the middle and the right. And I got 0.65.
I actually got 99.991.
Which ones do you have shaded?
The one's right of it. I'll share my screen. Can I see your screen? Okay, I thought we got the same Z-score.
don't know why it just changed that. 3.5, what was it, 2.357?
Uh-huh.
Yeah, so then it would be
99.
0.99.
Okay, perfect.
For some reason it just changed it.
It was 0.99, right?
0.991.
Okay. I just got that too. Okay.
Okay, my turn. Which one of the following best describes the notion of the significance level of a hypothesis test, the probability of obtaining a type 1 error?
I remember we had this one earlier. Okay. Number 11. The heights of young adult females in the United States are said to have a population standard deviation of 2.6. Sample was taken of 85 young adult females at BYUI, and the mean was computed to be 65.4. Which of the following explanations describe the correct way to interpret? So it would be the third one. No, not approximate. It is the very last one.
Well,
We are
it might be the third and the last one because it's one of those ones where you check all that are true.
Oh, it did say that. I don't think approximately is a word we use.
Right.
So definitely the last one. I think maybe the second one. Because we don't use chance, we don't use.
It's not the first one.
95% of the heights of female. Yeah, it's not all. You're right. I don't want to put all in there.
Just in our sample.
So the first one and the last one?
That's it. I'm thinking, yeah. I know it's not chance and approximately. Yeah, I agree. First one, last one. Thank you.
Marine biologists have been studying the effects of acidification on the oceans of the weights of in the Arctic Ocean. One of the studies involves a random sample of 16 beluga whales. The researchers want to create a 95% confidence interval to estimate the true mean weight of male beluga whales. Data following normal distribution, population standard deviation of weight of male beluga whales is standard deviation of 125 kilograms, and the researchers feel comfortable using this standard deviation for their confidence interval. Are the requirements for the use of a met? I think no, because distribution of sample means is not normal because the sample size is small.
But didn't it say that their data follows a normal distribution? So they don't have to have a big sample? So like, yes, the distribution sample means is normal because the data is normal?
Yeah, that makes sense.
Yeah, I read over that part and I was like, wait, is it in there? I had to go back to like reread it.
So that was a trick question.
Yeah, it was. Look this way.
Which is the very best?
Okay, an investor with a stock portfolio worth $7,000 sued his broker and brokerage firm because he felt the lack of diversification in his portfolio led to poor performance for many years in a row. Blah 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 blah. Ooh. 39 months. Same period. Suppose you are, okay, so the population mean is 0.95. So we need to download this real fast. Ah, dang, I'm on a different computer. Which one do we need to use? The quantitative sheet or?
I believe it's the quantitative one. As you're doing, as I get it open to you.
You know where we can download those?
It's on your in your assignment place where you can read the lessons.
Yeah.
It will have the date of things. I have to find it, but I did that myself. So let me go to that. I went to the lesson, and my computer's kind of slow. Sorry, right now. So much stuff going on. It should be on this side of your box. Side. I just saw your screen pop up.
Yeah.
Over here on the. Yeah. Yes, on your data level.
Is quantitative.
Did it pop up for you?
Still looking.
So I told you the wrong one. Oh, you're looking for those other three. Okay, I'm sorry. I thought you were looking for the rates of return. Sorry.
What?
Well, that didn't work, right?
You could go to lesson 3, and in the first, after step 3, there's a blue box with Excel instructions. There's a link to it in there.
Got it. Thank you. Let's see here. Okay. Back to the lesson.
I don't know. I got 0.0126. I don't know if that's right.
Which one do we need? The
The p-value.
Which one?
The population mean is 0.95, right?
Mhm.
So do we do that? I mean, what's the mean of this guy's rate of returns? Is it a negative 1.11? I'm a little bit.
So is this is a one sample t-test, right? Or is this the other test?
I just put it in the histogram and descriptive statistics. Am I supposed to put it in the other one?
Yeah.
The quantitative inference procedures.
That's the one I put it in.
Round two. So one sample test?
Yeah.
That's what I did it under.
Okay. So the mean is the null hypothesis is that it's 0.95, and we're wanting to know if it's less than 0.95, right?
Yeah.
So is it
Yep.
0.019? Is that what you got, Catherine?
Yeah, I did it earlier and I got a different answer, but that's what I have this second time. So yes, 0.19. Yes. Is that what you got, Ross?
No, what did you plug anything in differently? Other than just those numbers?
Well, the confidence is 95. The null is the null 95 too? 0.95?
Yeah.
And then the type of test is less than?
Yeah, I got 0.019.
Yeah, that's what I got.
Me too.
I did two of them.
All right.
Okay, go ahead.
Is it my turn?
Yeah.
All right. A financial economist is studying married couples in which both spouses work. He wants to compare the mean income earned with the mean income earned by their wife. Did he use independent sample, dependent sample? So that would be independent. The two are separate people with different jobs, so the husband income doesn't depend on his wife's income. So the third one.
I was thinking it was dependent.
Me too. I got the second one.
Yeah, I was thinking that too because they depend on, you have the husband, you have to have the wife.
So then the second one.
Yes. All right. Hopefully I can do this one right. Use the following for the next two questions. Pressures of supply and demand act directly on the prices of airline tickets. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. Allie Henrich, a BYU Idaho student, wanted to determine if there is a difference in the price of tickets listed 90 days before a flight compared with 14 days before the same flight. For her study, she compared the prices of a one-way flight from London Heathrow Airport to various destinations in Europe. Using Travelocity.com, she recorded the lowest published fares for 90 nonstop midweek flights 90 days in advance, and then found the lowest published price for the same destination, again, 14 days in advance. The prices in US dollars are given in this file. Notice that for some destinations, flights were not available. What is the p-value for this test? I did that earlier, but I got 0.96, but let me redo it. 0.096. I don't know.
Is that a paired sample t-test?
Yes.
Yeah.
Awesome. You do 14 days in variable 1 and 90 days in variable 2.
Yeah, it shouldn't make a difference, really. Did it? I actually don't know. But yeah, I did. I just copied and pasted it the way they had it.
Yeah, I did too. So I got 0.095, and then the next number was 6, so it's 0.09, 0.096. Is that what you guys got?
Yeah, I got that.
Yeah, that's right.
It's like the tongue tied.
Me too. But like all the time, I'm tongue-tied. Okay, based on the results of the test, you can say there's a difference in the cost. Can you say there's a difference in the cost of airline tickets? Significance level 0.05. I would say no, because the p-value was greater than the level of significance.
I agree there. Okay.
A real estate company wants to evaluate 2 of their home appraisers for consistency in preparation for their annual state certification. It is important that appraisers be able to give similar estimates on other properties. Company selects a random sample of 10 homes in different neighborhoods around the city and independently asks each appraiser for an estimate of the home value. After they receive estimates for each home, the company subtracts the value given by the first appraiser from the value given by the second. They create a QQ plot of the differences and see that the points in the plot roughly form a straight line. The requirements for using desired boundary satisfied. I think the last one.
I was thinking that was a yes, but because if it roughly forms a straight line, doesn't that mean it's normal?
Yeah, but I think it needs to be a straight line on the QQ plot and have like a larger number to satisfy that part.
Okay, I agree with the larger number. Okay.
So the last one?
Yeah.
think so.
Okey-dokey.
I'm gonna go with that. Okay, and now suppose the company of the previous question wants to use a hypothesis test to determine whether the estimates given by the two appraisers are different. Which of the following would be the most appropriate pair of hypothesis for such a test? I would say, see what I thought before. I was a little confused whether it was the 1 and 2 or the difference. But it did say difference, didn't it? So I'm going to say the third one. But then again, he used 1 and 2. So it's either first or third. I don't know for sure.
I think that's the. I guess it could be the first one or the third one.
I think it's.
Oh, I think it's probably the third one because it says it's a test of differences.
Yeah.
Okay, that was my first assumption. Okay, that sounds good to me.
We'll find out.
Yeah.
My apartment is like freezing. Okay, number 19. Suppose you create a 95% confidence interval for a mean and get that as your confidence interval. You've been told to report this by saying we're 95% confident that the true mean is between so and so. Exactly what does this mean? I remember this one with Catherine. 95% of all 95 confidence intervals actually contain the true mean.
Yeah,
Yeah.
I agree.
If P equals 4/5, what is the smallest value of n that satisfies the requirement for a normally distributed P?
I forgot how to do this.
Doesn't it have to equal or have to be greater than or equal to 10?
Mm-hmm.
P minus P greater than or equal to 10, right?
Mm-hmm.
So,
So what are you doing with this?
10 divided by 0.2.
what was that?
So it should be 10 divided by 0.2 to find n.
And divided by
Because
what?
1 minus 4 over 5 is 1 over 5, which is 0.2. So 0.2 times n needs to equal 10. So if you solve for n, it's 10 divided by 0.2, and that's how you get n.
I got 50.
Me too.
Okay. 21. Your little brother has a career batting average of 0.233. You want to determine the probability that he will have a batting average of over 0.250 next season when he will be up at bat 40 times. Are the conditions met so the sample portion p hat will be approximately normal? Well, if I did the second one, it ends up being 10. If I do the last one, it ends up being 9.3. So
Which one is P and which one is P hat?
I don't know.
I feel like P is the 0.233.
So that yes and no depend, Tim. So
P is the population. P hat is the statistic. So if P is the population, then it's what his batting average is right now. So it'd be 0.233.
okay, so the answer is no then, because it's a 9.32 if you do 40 times.
Tinkum.
Would you agree it's no, the last
Yeah.
one?
Yeah, I think it's the last one.
A geneticist, I'm going to turn the volume down because I can hear myself, takes a random sample of n equals 140 gamete cells from the tests of a dog to determine the proportion, which is known, the chromosome for development into a male. Assume the unknown proportion of dog gametes that contain the male chromosome is 46%. And that would be P. The geneticist conveys her survey and calculates P hat equals 0.512. Which of the following is the most accurate interpretation of the statistic? I say it's the last one.
Yeah, I would agree.
Yeah, I think so too.
Yeah, chance is not in there. And all wouldn't be word. Okay.
Researchers published a study in which they considered the incidence among the elderly of mental health disorder, obsessive compulsive disorder, delirium, and Alzheimer's disease. In the U.S., 45% of adults over 65 suffer from one or more of the conditions considered in the study. Calculate the probability that fewer than 320 out of the 750 adults over 65 in the study suffer from one or more of the conditions under consideration. Go to 3 decimals. So That would be one sample proportion.
Mm-hmm.
So we put X as 3. What's the null hypothesis?
What's that?
Do we have a null hypothesis number that we could put in?
0.445.
Uh,
I think.
That fewer.
You're confident you're keeping it at 95, right?
Yeah.
So are you doing greater than?
Yeah, I did less than. Or,
Okay.
the z-score negative 1.84.
Yeah.
Mm-hmm.
Negative 1.284. Okay.
And the probability I got was 0.0 or 0.100.
Mm.
What question did you just did 23, right?
Yeah.
Okay.
Okay, so my question is, what's the p-value down at the bottom that says next to the z-score? So I think that z-score tells us the probability of getting 320 of getting 0.427 instead of 0.45. I don't think we did that right.
So you did X is 320 and N is 750.
Yeah.
Mm-hmm.
Well, isn't the p-value the probability?
So my question is on the spot that says one proportion z-test. There's the z-score of negative 1.284, and then there's the p-value there. And that p-value doesn't match up with the p-value that we have on our applet. So I'm wondering which one it is. Does that make sense?
Yeah.
Yeah, it does. I'm thinking it's the p-value on the Excel sheet that we should go for.
Hey, well, if it's wrong, we know how to go back and try something new.
Yeah.
Yep.
0.099. Okay. Is it my turn?
Mm-hmm.
Okay. Suppose you're testing those numbers against those numbers, and you have calculated the test statistic to be z equals 1.334. The area to the right of the z equals 1.334. Under the standard normal density curve is 0.091. Which of the following is the p-value of your hypothesis? 0.091.
Yeah.
Okay. That was easy one.
Yeah, it's one of, you're not overthinking it, Catherine. That's great.
That's the first time.
I was about to overthink it. I was like, let's see. Suppose you are a dog breeder. Why do I get all these dog questions?
Do you have a dog?
No, I don't. I'm not allowed
Supposed to have a dog then.
Yeah, apparently I'm supposed to have a dog. I agree.
Okay.
Suppose you're a dog breeder and you want to use a confidence interval to estimate the true mean fertility levels of purebred Cocker Spaniels. It is known that the distribution of fertility levels is normal. How many measurements would you have to take in order for the sampling to be normal? Ew. I think it's the last one. Because it's not a... Is it a proportion? Nope. Yeah, I think it's the last one.
Any N will do?
Mm-hmm.
I would agree.
Yeah.
Hey, we're more than halfway through. Woohoo!
Getting there.
Study is planned to compare the proportion of men who dislike anchovies with the proportion of women who dislike anchovies. The study seeks to determine if the proportions of men and women who dislike anchovies are different. A sample of 41 men was taken. Estimate for the proportion of men who dislike anchovies was determined to be 0.67. For 56 women was also taken. Estimate proportion of women who dislike anchovies determined to be 0.84. Are the requirements satisfied to perform this hypothesis test? Why?
I'd be one of those women.
56. Is it yes because it's greater than 5?
I don't know. I was thinking it was just the other one because they're both.
I thought it was no because the women was less than 10.
Oh, was it?
1 minus 0.84 times 56. Yeah, it's 8.96.
Oh, then yeah, it'd be that bottom no.
Okay, no.
The last one.
Okay. My turn again? Comes around fast. Okay, a study was conducted to measure the effectiveness of a diet program that claims to help manage weight. Subjects were randomly selected to participate. Before beginning the program, each participant was given a score based on his or her fitness level. After 6 months of following the diet, each participant received another score. Study wanted to test whether the difference was between before and after scores. What is the correct alternative hypothesis? I would say that it is the second one. The UD, whatever you think?
I don't think so because the first time they study, their score, there's no difference.
Mhm.
So we're comparing the first score and the second score in this case.
Okay.
Yeah.
That makes sense. Thank you.
Or it goes at U1 equals U2 or P1 equals, or does it? U2.
So the third one, you won? Okay.
I'm not sure if it's the third one or the fourth one.
I think it's the third one.
All right. Weight Watchers wanted to predict how much weight a client would lose if they followed a prescribed exercise program in addition to their diet program. Volunteers were randomly divided into two groups. One group dieted but didn't exercise. The other group dieted and followed the exercise program. For the exercise group, they used their linear regression with percent compliance. Ugh, what are these words mean? The linear regression. Okay, with percent compliance with the exercise program as the explanatory variable, and the pounds lost in 3 months as the response variable. One of the clients was told his residual was 5.5 pounds. What does this mean? That's the difference between his explanatory variable and response variable, right? No?
And I don't know, I'm kind of lost on this one.
I'm going to Google what the variable is.
It's just whether it's predicted or actual. 'Cause all the rest are pretty much the same.
Oh, it is. It's the difference between the predicted and the actual, which means it's y, which is the minus y, which means he
The first one?
lost more than they predicted. He lost 5.5 pounds. Yep, the first one. No,
Is it the second
the
one?
third one. His actual, yeah, the second.
Because it's the actual is the word first and not predicted.
Mhm.
Okay.
Because it's actual minus predicted is the residual. So if it's 5.5, that means the actual was larger than the predicted, which means he lost more weight than the predicted. Yeah, so the second one.
Okay, I'll write that down. Thank you.
All right. For the study in this previous question, the B1 of the regression line was 5 pounds in terms of the statistic. Would it be the third one?
Yeah, that's what I say. That's what I read somewhere is every percent goes up, whatever that other number was, is that what it goes up.
And which one did you get?
As percent compliance goes up by 1%. So it's the third one.
Yeah, I agree.
Okay.
When creating a scatter plot, a residual plot, and a QQ plot, which of the 5 assumptions about linear regression are being checked? I know I got this one right.
I really don't like this one.
Okay, I looked up this earlier.
Good.
So the X values are measured without error is yes. And the observations are independent is yes. And there is a linear relationship between X and Y, yes. And the variance of the error team is constant for all. Yes, the only one is that middle one.
The only one not in there is the second one.
Yes, that's what I found in my answers.
Yeah, that sounds good to me. This is a long one.
Yeah.
We're talking about the supply and demand on the price of airline tickets. As seats are available, the plane began to fill, the airlines raise the price. If it's not selling well, they discount the tickets. Allie Henrik, a BYU student, wanted to predict the price of tickets 14 days before a flight based on the price of tickets listed 90 days before the same flight. From her study, she compared the prices of one-way flights from London's Heathrow Airport. Remember this one? Okay. Huh. So she wanted to predict the price. So that's the response variable. So that means we're going to copy 14-day list and put it in the Y column. Oops. And put the 90-day column in the explanatory. Does that sound right to you guys?
Yeah, I think so.
I think so too.
I see what they did there. Tricky. So that's what that's gonna look like. And
So wouldn't that just be copying and pasting how it is?
No. The
It's
14-day column goes in the Y column, and the 90-day column goes in the X column. So I think you switch them.
Got it.
So compute the example correlation coefficient.
Which is what, the slope B1, right?
I thought that was R.
Oh, you're right. It is.
R is the coefficient.
You're right. R is.
Okay, good, because last time I took a quiz, I messed that up. So I learned from it.
Did you get 0.780?
Yeah.
Yes, that's what I got too.
All right. Create a scatter plot using these two variables, using the scatter plot and referring to the correlation coefficient. Select the answer that best describes data illustrated scatter plot. It looks linear with a fairly strong positive.
I agree. And I think that it's all positive. I mean, there's not any really negatives.
Can I see your scatter plot?
Yeah.
Oh, okay. What's the second scatter plot we do with the residual? What's that one for?
I think it's basically the same thing, but we're checking to see if it's like hot dog shaped, hamburger shaped, or
So we're not using the other one, not the residual scatter plot.
not for this one. I think it would actually ask for the residual
Yeah.
data.
Gotcha. Okay, so you did linear with a fairly strong positive association.
Yeah.
Okay, cool.
Okay. For the next two questions, compute the y-intercept and the slope of the linear regression line used to predict the price of tickets 14 days before a flight based on the price of tickets listed 90 days before the same flight. What is the y-intercept? It's a good question. I don't know. All right, I see your answer. That's awesome. We'll go with your answer. Where did you get that answer from?
If you look on the left side of my screen, I'll highlight it yellow right there. You see it, Catherine?
I just see your answer at the moment.
So if you look on, oh, I'll just make it big. Do you see this yellow box?
No, I think I'm just messing up. That's all right. We can keep going.
Are you sure?
Yeah.
You just
Yeah.
have to.
Spreadsheet.
I don't know how to. Okay, let me get out of the box. Hold on. Let me unclick that and go back to you.
So yeah, on the t-test, this one right here is the y-intercept, I think. That box I have.
Yeah.
That one.
Okay. Okay. 115.640.
Is that what you got?
Yeah, that's what I got. And then the slope is just right below that at 0.627.
I don't know if I can predict the price of tickets listed 14 days before a flight based on the same flight costing $200, 90 days before a flight. Give your answer to accurate to 1 decimal place. How am I going to do that? Am I putting that in the...
Yeah, so that blue box on the screen where it says X and underneath is a blue box, you just type 200 in there.
That's what I thought, but I didn't know for a fact.
Yeah.
Okay. All right, computer, come on. So I'm giving the predicted is 177.307.
I got 241.
Me too.
Okay. Okay, I'll go with you guys. It's 241.
Wait,
Okay.
show me your screen.
I don't know how to do that very well.
Oh, it's okay. Can you look at my screen?
Yeah.
Do you see this right here? The 200 is where, did you type in 200 right here?
I did?
And you still got a different answer?
Yeah. I picked in 200 in the blue box, yeah. But I could have been done something else.
Did you put the 14-day in the response variable?
No.
And the other, oh, so you had it switched around?
Yeah.
Oh, yeah.
Okay. That's where I messed up. Okay. I'm glad I have you guys. Thank you. One last time to save me through this stuff.
Oh, that's so sad. That's sad. I don't want to think about that. All
Me
right.
either. You've been a lifesaver.
You're the sweetest. Okay, for the next three questions, construct a 95% confidence interval for the slope of a regression. What is the lower bound of your confidence interval? Next. So if we're going off of the slope, then the lower bound would be 0.518.
Yeah, that's what I got.
And I can just do the other one because I'm pretty sure together they equal 0.735 for the upper bound.
Yeah.
735?
Yeah.
It's all messed up. Okay.
Undetermined margin of error. I got 0.108.
Oops. You got 0.109.
I got 0.108.
Did you round the last decimal spot?
Yeah, mine goes 0.10824.
You did 0.518 minus 0.734 divided by 2?
Yeah, so I did the 0.735 minus 0.518 divided by 2.
Shouldn't we be getting a final read?
And when I did, I got negative 0.1. Let me redo mine.
Well, I just got something different.
I got 0.1085. So
See, that's what I got too. And then I just rounded up to 109.
yeah, 109. That's what I got.
Oh, what I did was I took the actual points in the Excel, so it's probably rounded differently.
Oh, that makes sense.
So 0.109.
Yeah, I think so.
Okay. Choose the correct. Did I miss the question? No, I didn't. For the next 4 questions, choose the correct null and hypothesis test for this analysis. That for the one right above, right?
Mm-hmm.
I don't know.
So we're testing to see if it's linear or not linear. So you're gonna want to. The test is gonna be based off of B1 or that whatever the symbol means.
Yeah, B1 is the slope.
Yeah. So the slope tells you if it's linear or not. So
Okay.
if it's then the null hypothesis would be that it's not linear. So B1 is 0, so it's a straight line. But the alternative is that it's actually a linear, which means there's going to be a slope, which would be B1 is not equal to 0, that there is a slope.
Okay.
Does that make sense?
Yeah, does looking at the linear one is okay. Yes.
What's the difference between the regular B1 and the like the beta B1?
Oh, I don't know actually.
Because
You
normal
think it's the second one?
B1 is, it might be because the slope, the Excel sheet, it says that it's lowercase b1.
I thought in the text it was fancy B, but let me check really fast.
Yeah.
I think it was less than 22.
Yeah, the little b is the slope, sample slope.
Yeah, I think you're right. I think it's the second one.
The other one's the population slope.
Oh, okay. The second one.
Okay.
What is the value of the test statistic? I don't know. Is it 6.525 or 11.510? I want to say it's 11.510.
Yeah, from what I've seen, pretty much it's always been off of the slope that they ask all these questions.
Yeah.
11.510.
Yeah,
Okay.
and the p-value would be 0.000.
Yeah.
Okay. What decision do you make based on the p-value and the level of significance of 0.05, and thus what do you conclude? See, if p is low, you reject the null. P is low, so we reject. And it would be the third one.
Yep.
Took me a few weeks to memorize if p is low.
Me too. I'm like, yes, it's the end of the class and I get it.
Yeah, that was it. It's like, great.
Yeah. Okay. In the U.S., mothers who live in poverty generally have babies with lower birth weights. The mean birth weight for babies born in the U.S. for mothers living in poverty is 2,800 grams. The CDC carries out a study to test the effectiveness of a new prenatal care program, reducing the number of low birth weight babies born. 30 mothers, all of whom live in poverty, participate in the program, and birth weight is recorded. Which hypothesis test would be most appropriate for this study? Oh. So we're gonna.
It's either the ANOVA or the CHI, right?
I think it's actually the independent. No, I think it's the one sample. It's either the T or the Z test because we know the population for poverty mother weight, so we're comparing our sample to a population, which would be a one sample, either Z or T test. I can't remember what the difference between the two is.
Yeah, I'm not sure either.
Let's see if I have it on my paper.
I remember last time Catherine had it in her notes.
Yeah. I have too many notes. Let me tell you, sometimes I like, what?
Oh, it's whether you know the population standard deviation.
So the one sample Z test is where you know the standard deviation. The one sample T one is where the standard is unknown.
So would it be?
Okay, so I'm looking at this thing online and it says if n is greater than or equal to 30, then the standard deviation is known and it's a Z test. If our sample size was less than 30, then the standard deviation is unknown and it would be a t-test. Does that sound
this one would
familiar,
be
guys?
the z-test because it's 30.
Yeah, I think it's the one sample z-test. If not, we can fix it.
Oh, we get another chance.
Yeah.
Yeah.
Engineers at an oil refinery find out how easily gasoline evaporates by measuring its vapor pressure. As they make gasoline, they need to determine whether its vapor pressure is high enough. The standard deviation of the vapor pressure of the gasoline made by the refinery is always 0.03 pounds per square inch. Which hypothesis would be most appropriate for this task? Um,
I think the standard deviation is one. Helps us.
yeah, I think it's a z-test then.
I do too. Which makes the other one, I don't know if we have both the same answers.
Looking at that thing that you pulled up, Lily, it looked like it was n has to be greater than 30.
Greater than or equal to.
Oh, greater than or equal to. Hmm.
Like I said, we have another shot at it. Okay, number 45. An attorney wants to know whether the percentage of Walmart employees in Nevada who are over 45 years old is more than 30%. Which procedure would be most appropriate in this situation? That is the one proportion.
Yeah, I think so.
Test of
Yeah, it has a percentage, so how I kind of go by it.
Okay. 46.
Mm-hmm.
Marriage counselor conducted a study on couples, categorizing them as communicative or not. Wanted to see whether the percentage of communicative couples whose marriage ended in separation or divorce was the same as percentage of non-communicative couples. Oh, that's a very good study. I would say independent sample t-test. Is that right? Or no, are we? It's a proportion test.
Yeah, I think it's two proportions.
Okay. Yeah.
A business marketing firm specializes in radio advertising. They hope to show buyers a linear relationship between sales and the amount of money a client invests in radio advertising. Which procedure would be most appropriate? I think that is linear regression.
Yeah, that was a pretty easy one. Can I get 1 through 5 from you guys real fast?
Yes.
Or 2 through 5, actually. Actually, let's see.
All right. 2, we got the second and third one.
Okay, good. Me too.
Question 3, we got the second one.
Okay, awesome. Bueno.
Question
And
4.
fourth one.
I got the third one.
Okay. And fifth one.
And 2.5.
How did you get that? 2.5?
Yeah.
Okay. Oh, no, that makes sense. Yeah. Who wants to turn the test in?
Well, I will, but oh, there it went. Saved it. Just saved it all. I can submit it.
Okay.
All right, here we go. Question 2 is wrong.
Oh, man.
And question 11, we got 0.6 out of the 1 point. That means there's one more in there.
Which one?
And question 11, we only got 3/4 of 0.6 of it.
Number 1, number 2, it's only the
Is it
last.
on the third one?
Yeah. Sorry.
Yeah,
And then the next one was 11.
So what did you get on 2?
It should just
That
be the
last one.
last.
That even though it says mark all that apply, that was a trick
Yeah.
question.
Trick.
Okay, just let me write these down as we're going through them so I can make sure I go back. Last one. Okay.
Number 11.
Yeah, number 11, we got 0.6 out of the 1.
I think it's just the last one.
So if we got 0.6, that means that we just missed one of them.
2, 3, 4. It could mean that we marked one that shouldn't have been marked, right?
Well, yeah, I guess, yeah. That's another mark, all the apply, confusing. I think it's probably just the last one too.
Okay. What else?
Okay, and then, all right, keep going. Number 17. That's pretty good so far, only 3 wrong.
Yeah, great.
So it has to be a yes then, right? Because not necessarily wouldn't be one of the answers.
Would it be the third one then?
Yeah, got to be the third one. I
Sorry.
missed in there where it said it was normal.
Yeah, me too.
Okay.
Oh, yeah, straight line is normal.
Okay, and then
Sure the heat is on.
number 24. The one I got wrong. Thought I knew what that one was.
24 was wrong, man. The
24.
one time we didn't overthink it.
I know, I guess we should have overthought it. I don't even. Maybe I have to put 0.91 in the, no?
Suppose. Okay. I think it's supposed to be the left and the right, so I think it's 0.091 plus 0.091, which would be 0.182.
Yeah.
Because it's the not equal to test, which means we need the left and the right, not just the right.
Yeah.
That makes sense. Okay, and then number 27.
So then would that be the P1, P2?
Yeah, gotta be that one.
Okay, and
Because I guess because it's the true population per person, yeah.
Mhm.
That makes sense because it is that person's population.
Yeah.
What else we got?
Okay, so number 30, then I thought was so right. We got 0.4.
So we probably checked one that's not true. Maybe the 1, 2, 3, fourth one, the linear relationship, because I know 1, 3, and 5 are right.
Okay, we'll try 1, 3, and 5. And let's see. Number 39.
That's a good jump. Ah, is it B1?
Has to be the other B's then.
Yeah.
The
The
big
last.
B?
Okay,
All right.
and 43.
Ah, so that one has got to be the second one.
Yeah.
Yeah, I was worried about that because I was like, I never heard that before. So don't trust the internet 100% of the time, kids.
Really? Okay, that's it. We got 7 wrong, right? 1, 2, 3, 4, 5, 6, 7. It says 8. I got 40 out of 47 according to the score.
I'll go ahead and submit mine.
Okay.
Hmm. 11. Now we have 0.8 out of 1. So there's got to be a second one in there that's right.
And 11?
Yeah, an 11. Hey, we did really good. Number 27 is still wrong. Wait, what'd you guys do for 27?
27?
Yeah.
The P1? P2?
Yeah, that one's not right.
All right, so number 11. What percentage did we get on 11? If we took that one.
0.8.
Well, that's
So
weird.
11, 27. Okay, and number 30, we got a worse. We got 0.2 out of 1, which means the linear relationship is true, which means maybe it's the third one. Observations are independent. Maybe that's the one that's not true.
So which one are you looking at?
Number 30.
Number 30? Let me go down to 30.
30 is only... Okay, so 30, 11, and what was the other one?
That was it.
Was it 27?
27.
Okay, so 30 is what were we thinking?
So we need to put back linear relationship between X and Y.
Yeah.
Yeah, where do I have those notes? I still think they're wrong because it says the 5 requirements for linear regression is 1, there is a linear relationship between X and Y.
So that one is true.
So 2 is the error term is normally distributed. Number 3 is the variance of the error terms is constant for all values of X.
So the last one is right.
So we got the last 2 are right for sure. The X's are fixed and measured without error.
So the top one is right.
And the observations are independent.
Isn't that what we had the first time? All four
Yeah,
of them?
that's exactly what we had the exact time they did.
They must all be true then.
Yeah.
Because, yeah.
I guess
Well,
so.
where does it say the residuals are normally distributed?
Well, I mean, if we don't click on that one, then
Yeah,
we're
that's
back at
cool.
what we put originally.
Right. All right. So Ross, you get to click on all of them, and we'll see if you're.
And I think 27, I think we'll do the UD not equal to 0.
Yep.
Let me get to that one. 27.
I thought that's what we put the first time. Is that not it?
No, we did the U1 not equal to U2.
Oh, okay, I remember now.
Okay. So then the other one was 11, right?
Yeah.
Yeah.
And didn't.
So 11.
These are for you.
Do you think it's the second one?
Let's try it.
All right, Ross, you try those, and then you let us know, and we'll come back.
Alrighty.
If you need to go home, Joseph, that's fine.
I don't know. According to my property manager, Campus Way is my home.
Question 11, we got 0.6 out of 1.
Yeah, that's what we got the first time.
So it went down again, which
That's-
means it's not the first one, it's not the second one.
So we know
What about the second to last one and the last one? Or is it the third to last one and the last one?
I don't think they use approximately ever, or there's no chance. They don't use chance or approximately.
Well, it's gotta be.
Which ones did you do, Lily? You clicked them.
When I did it, it was just the last one. So
Okay.
we've tried the last one, we've tried the last one with the first one, the last one with the second one.
Huh.
Something with AA batteries in it.
We know the last one is right.
Yeah.
Yeah.
Where's your garbage can? Fucking take it.
Number 30, you went to 0.6.
A while? I don't know.
We went from 0.6 to what?
I'm not sure what we had last time, but we have 0.6 now.
What did we decide to do for 11?
We haven't decided.
Okay.
We jumped to 30 though. Okay.
Sorry, I'm trying to type these answers back in.
Yeah, I'm just trying to write them down. So 11 we're still working on, and 30. Ross, were those the only two wrong ones?
Yeah.
Okay, so 30. And you clicked all of them, Ross? Every one of them?
Yeah, I did.
Hey, Nance. Hey. Okay, I'm almost finished here. Thanks. All right. Bye.
You going out to party, Catherine?
I'm going to go watch that movie Wonder with my sister from Arizona.
Oh, that's fun.
Yeah, she wanted to see it, and I'm going to stay up late tonight.
Ooh, partying.
Yeah, unusual for me to stay till midnight, so.
There you go.
I'm off work tomorrow, which is very nice, so.
That's nice.
Okay, so on 30, we clicked all of them, and we've done 4 of them. And when you did it, Leela, you took out the linear one, right? And we went down in score. This doesn't make any sense. I think they're wrong. So I wrote those all down and they were in the reading. What are the residuals anyway?
Residual is the difference between the predicted and the actual and the predicted. Okay. So wait, what happened to our score? It went down, or what was the score on 30?
On number 30, it was 0.6.
Oh, so it went up.
Maybe it's the first one. It says the X values are fixed. Maybe we're just doing half that one because it should say the X values are fixed and measured without error. I don't know.
Observations are independent. Okay, let me pull up the lesson. Do you guys remember what lesson it was?
23. So we're kind of stuck on 11 and 30. That was the only two, right, Ross, that we got wrong?
Yeah.
Okay. When creating a scatter plot, a residual plot, and a QQ plot, which of the 5 assumptions are being checked? A linear relationship. Observation.
I did not know. But that's what. Which one's that one? The one broken symbol. Oh yeah, the other one has the yellow on it.
Oh no, I said we lost this.
Because they're all
Okay.
there. Yeah, it's nothing, and nothing else could be different. Right? Is that what you're
Yeah.
saying?
Yeah. And you've got a movie to go to, so
Well, just decide on 11 and we'll.
You're surprised how much that works. Oh no, I know how that is.
So, Ross, what did we get 0.6 on 30 with doing that?
Yeah.
Okay, on 30, what did we click? Every one of them?
Yeah, the last time we clicked column.
And you got 0.6?
Yeah.
That doesn't even make any sense. Well, it's higher than 0.4.
I've got it wrong, guys. What did we decide to do with 11?
How does your day consist of? Eaters?
I know it's not chance. I know it's not that one. So maybe just try the third one.
So it'll be a third and the last, or?
Yeah, that's the only other ones we haven't tried because I know it's not chance for a fact.
Where do you live at?
They've told us never to say chance in those things. So
Are we just gonna do all of them on 30?
yeah, that's higher than 0.4 what I got when I didn't click the one.
So the third one?
Yeah, third one. We'll try the third one and the last one.
Third and last.
I want to go to your bedroom. If you want to do.
Maybe.
Oh, maybe. Like how you missed about that.
Okay. Did anyone submit that?
Yeah.
Not yet. I'm still typing in answers.
Okay. Okay.
People that were commenting,
Okay. 11.
I'll just be sitting there on my bed. We'll be watching. Exactly. It's like freezer in here. Okay. You have this one. Both of them can go. Don't touch this. I told you. And we're just, yeah, you need to get permission to call.
Permission granted.
I also need to get permission from the property manager for 210 because that will make it.
Do they have space tonight?
Yeah, that's for the nice space. I'm just happy I found it downstairs in the midst of a bunch of broken.
What about the heater at Campus Way?
That one's on his schedule for tomorrow, so I'm hoping he does all three.
And they have space tonight too?
Oh yeah, they've had
Awesome.
Awesome.
Okay, I'm gonna submit this to this guy.
Okay.
We'll have fun for them.
Okay, so the Joseph.
You won't be like Bill.
I know. And 11 is right.
11 is right.
Yeah.
All right. And the 30, you left it the same?
Get in there. Yeah, 0.6 out of 1. That's kind of weird.
Yeah, totally is.
All right.
Okay.
It's been fun, guys.
Yeah, you guys are awesome.
Thanks
Yeah,
for
do we meet on Monday? One more time?
I don't think so. I think we just take the final next week.
Yeah, I think this was it.
So good luck.
Yeah, same for all of you. It's been a great.
Did we project and everything already?
What?
The project we did, that's all done, right?
We're still working on it.
Okay. What else do we need to turn in?
I just have to write up a paper, and Catherine has to do
The power.
PowerPoint.
Okay. Awesome. Does anyone need any help?
Not yet. I don't know what I'm doing quite yet. I have to look at some of the other PowerPoints. Then if I do, I'll let you know.
Okay, let me know. I'll check and let you know.
Okay.
Okay.
Wonderful. Thank you very much. You guys are awesome. It does say less than 25 group meeting, just so you know. I don't know what that means, but
Okay.
it may be one more time. All right, have a good night.
All right, see ya.
Thank you.